Hi children, good morning. Today we are going to discuss about third state of matter. So before starting, let's recollect what we have learned in the last classes about states of matter. There are mainly three states of matter, which are they? Solid, liquid and gases. In the previous classes we studied in detail about solid state and also about liquid state. And today we are going to discuss about the gaseous state. Okay? The gaseous state, third state of matter. Gaseous state. Third state of matter. Have you ever seen a balloon seller? How many balloons can he fill from one cylinder of gas? Let us do an activity in order to study the characteristic properties of gaseous state. Activity 1.11. What's that? Take 300 ml syringes and close their nozzles by rubber corks. Stop their nozzles. Okay? Then remove the pistons from all the syringes, leaving one syringe untouched. Next, fill water in the second and piece of chalk in the third. Insert the pistons back into the syringes. You may apply some Vaseline on the piston before inserting them into the syringes for their smooth movement. Now try to compress the content by pushing the piston in each syringe. What do you observe? In which case was the piston easily pushed in? What do you infer from your observations? See, let us discuss in detail about this activity. Take 3 syringes and remove its piston. Then close its nozzle using a rubber cork. And listen, keep one syringe untouched, second one fill with water, and third one fill with the chalk powder. After that, we have to mix the piston with some Vaseline in order for their smooth movement. And let's introduce these 3 pistons in each syringes. Then after that, let us compress them by removing the rubber cork that we already placed at the nozzle. Okay, just remove. And as we know, in which syringe it is easy to push the nose piston? In the untouched one, or filled with water, or filled with chalk powder? Yeah, what's the answer? Yes, very good. The first one itself, untouched. That is, it is full of air. In second one it is water. And third one it is chalk powder. Air, as we know, it is the gaseous state, matter in its gaseous state. Water is a water in its liquid state. And third one, chalk powder in its solid state. Very good. Okay, then what do you observe? Yes, it is easy to compress the piston in the case of an untouched syringe itself. No doubt. Why? As we know, gases are easily compressible. While studying the compressibility, in the case of solids and liquids, we have seen that solids are incompressible in nature. Then what about liquids? Yeah, it is not much hard as that of solid. Then here the gases are highly compressible as compared to that of solids and liquids. That is why the liquefied petroleum gas we use in our house for cooking, or the oxygen supplying cylinders in hospitals, or the compressed natural gas used as fuel in these days in vehicles. Because of this compressibility nature of gases, we can use LPG, that is liquefied petroleum gas. Petroleum gas used for cooking, LPG, and oxygen cylinders in hospital. Did you see? Yes. And nowadays we are using CNG, fuels for vehicle, CNG. What's the full form of CNG? It is the compressed natural gas. Compressed natural gas. Compressed natural gas, CNG. So, due to the large compressibility of gases, large volumes can be compressed into a small cylinder and transported easily. That is why CNG or LPG are used as fuels. Because of the high compressibility of gases, a large volumes can be compressed into a small cylinder itself. And also the transportation is also very easy. Then, as we know, we come to know of what is being cooked in the kitchen without even entering there by the smell of that reaches our nostrils. How does this smell reach us? The first topic itself, the hot sizzling food may reach our nose far meters away. Okay? Yes. Why? When the food items are in raw, the particles are in solid state. But while they are cooking, what will happen? It's vapors will produce. Vapors means gases will produce. And the rate of diffusion of gases is, so gases are very much more than that of solids and liquids. Okay? So the smell of a hot cooked food reaches us in seconds. Compare with that of solids and liquids. And here, why? As we know, while discussing the characteristic properties of solids and liquids, we discussed about the shape, then volume, compressibility, rigidity, intermolecular space, intermolecular forces of attraction, freedom of movement, kinetic energy. Okay, very good, very good. Okay, let us come to gaseous state itself. Let's discuss these points for gases also. See, in the gaseous state, the particles are moved randomly, and during their motion, they collide with each other, they hit with each other, and also on the walls of the container in which it is kept. And here they produce or exert pressure. What is pressure here? Pressure is the force per unit area. So when gases enclosed in a cylinder may exert pressure means they produce force per unit area on the walls. That is, they exert pressure. Okay, then let us discuss the characteristic properties of gases. What about the shape? Do they have fixed shape? No. Then what about their volume? What about their volumes? No, no fixed volume. Very good. In case of solids, fixed shape and fixed volume. In case of liquids, no fixed shape but has definite volume. Very good. In case of gases, there is no fixed shape and volume. Okay. Then, what about other properties? What about interparticle space? The interparticle space in gases are very large. As we know, they are loosely packed. They are very loosely packed. That's why interparticle space is maximum here. Then what about interparticle force of attraction? In the case of solids, interparticle force of attraction is maximum. Why? They are closely packed. But here, the interparticle force is very, very weak in the case of gases. And what about their nature? That is rigidity. As we have seen, solids are very rigid. Then what about liquids? The term we used is, what's that? Fluids. Very good. Fluids. Then what about gases? They are highly fluid. Highly fluid. Then can you say about the density? What's density really? Density, mass by volume. It's density, mass by volume. Mass by volume. Then can you say, what about the density of solids? It is very high. Liquids less than solids. And what about gases? Yeah, they have very low density. Very low density. Then what about the motion? Freedom of movement or kinetic energy? In the case of gases, it is very low. In liquids, comparatively high. And what about gases? It is very high. Then what about diffusion? In the case of solids, diffusion is negligible. And in the case of liquids, diffusion is slow. But it is more than that of solids, but less than that of gases. And gases, yeah, very fast. So let's tabulate or make a table or to compare the characteristics of three states of matter. Okay? After the class, you have to make 4 columns in the notebook. The first column is the property. Second column, the solid state. Next one, liquid state. And finally, gaseous state. Gaseous state. And you have to tabulate one by one. Tabulate one by one. Okay, first property. First property, shape. Then volume. Then intermolecular space. Intermolecular space. Fourth one, intermolecular force. Intermolecular force. Then final, fifth one, density. Very good. Density. Then sixth one, molecular motion. Molecular motion or kinetic energy. Or kinetic energy. Then, which is the seventh one? Yes? I think we forgot one. Rigidity. Very good, very good. Rigidity. Thank you. And finally, diffusion. So you have to mention these 8 points while studying the properties of solids, liquids and gases. Okay? And you have to write the first column in your notebook and complete for solids, liquids and gases. Okay students? I think it is very clear to you. Okay? Thank you.